Welcome to Study Loop.
We need to find the length of this value a given that the angle theta is equal to 45 degrees. And to solve this problem, we're going to need to find equations for the different lengths on this diagram: x of a, x of b, y of a, and y of b. So I went ahead and wrote out the equation for y of a, and we're going to start by taking a derivative of this y of a. So the derivative of y of a with respect to x, that's going to be equal to the hyperbolic sine of x of a divided by c. And we also know that the derivative of y of a with respect to x is equal to the tangent of theta. So we're going to take these two expressions and set them equal to each other. So we write down this first expression and then set it equal to the second expression. And then we can take this equation and solve for x of a. So x of a is equal to c times the inverse hyperbolic sine of the tangent of theta. And now we're going to look back at the free body diagram. And we notice that the length of the cable S, that's going to be equal to the length from A to C plus the length from C to B. So I'm going to write that. So we're going to write that S is equal to the length from A to C plus the length from C to B. And we can also write that as 10, since we know what S is. So we plug in 10 for S. And then AC is equal to C times the hyperbolic sine of x of a divided by c plus cb, which we can write as c times the hyperbolic sine of x of b divided by c. And then we can take that equation and solve for x of b. So we solve for x of b, and that's going to be c times the inverse hyperbolic sine of 10 divided by c minus the hyperbolic sine of x of a divided by c. So next I'm going to write out the equations for y of a and y of b. So the length y of a is equal to c times the hyperbolic cosine of x of a divided by c, and y of b is equal to c times the hyperbolic cosine of x of b divided by c. And now we're going to look at the free body diagram. And we notice that the tangent of this angle theta is going to be equal to this y of b minus y of a over this length x of a plus x of b. So we can then write that the tangent of theta is equal to y of b minus y of a divided by x of b plus x of a. So to solve this problem, in order to solve this problem, we need to choose a value of c. We need to choose some value of c and we plug it into this equation here, which I'll call equation 1. So we choose the value of c, and that will give us a value for x of a. So we can then take this value of x of a and plug it into this equation here using the same value of c, and this will be equation 2. And then this will give us a value of x of b. So after we get a value for x of a and a value of x of b, we can then use these two equations here. So this one's equation 3, and this one's equation 4. And we'll get values for the lengths y of a and y of b. And then since we know what theta is given as 45 degrees, we can then check to see if our values y of b, y of a, x of b, x of a are all correct by seeing if the tangent of 45 is equal to this expression here using those calculated lengths. So we're going to choose a value of c that's equal to 1.865 meters. So we take this value of c and we plug it into equation 1 here. And after plugging it into equation 1, we'll get a value x of a that's equal to 1.644 meters. So we take that value of x of a and plug it into equation 2, and then using the same value of c, we'll get a length x of b that's equal to 4.064 meters. And then we're going to go to equation 3, plug in the value of x of a, and we'll get a value y of a that's equal to 2.638 meters. And then we can take the value x of b, plug it into equation 4, and get a length y of b that's equal to 8.346 meters. So we then go to this equation here, which I'll call equation 5. So this is equation 5. And we know what the tangent of 45 is. And we now take these calculated values, plug them into these terms, and we can see that these terms are correct. Since if we plug in the terms here, they're going to be equal to whatever the tangent of 45 is. So these are the correct values. So now to solve for the length a, we do y of b minus y of a. So the length a is equal to y of b minus y of a. So we can write that a is equal to 8.346 minus 2.638, and that will give us a length that's equal to 5.708 meters.